Neurotransmitters are the brain's chemical messengers. Think of them as tiny couriers zipping around. They carry vital information between your nerve cells. These nerve cells are called neurons. Everything you think, feel and do relies on them. They are fundamental to the brain's internal communication system. Without these messengers, your brain would be a silent, isolated landscape. Imagine a world with no mail, no texts, no calls. That's a brain without neurotransmitters, a universe of quiet. These messengers play an absolutely crucial role. They bridge the gap. This tiny gap is called a synapse. It exists between one neuron and the next. Neurotransmitters are the way information makes the leap. They enable one nerve cell to talk to another. Consider it a microscopic spark of information, a chemical whisper. This process happens billions upon billions of times, every single second inside your magnificent brain. This constant communication is the bedrock of all brain activity, from the simplest reflex, like pulling your hand from heat, to the most complex thoughts, like pondering the universe, learning a new skill, remembering a cherished face, even the dreams that visit you in the dead of night. All of these are orchestrated by these tireless chemical signals. Your brain is a vast, intricate network of connections, pulsating with information guided by these molecular envoys. So what are they like, these neurotransmitters? Imagine them as highly specialized keys. Each type of neurotransmitter is a unique key. It is shaped to fit only specific locks. These locks are called receptors, found on other neurons. This precision ensures that messages are delivered to the correct address. It prevents signals from getting crossed in the brain's busy pathways. In this astonishingly complex biological machine, the universe within your skull, accuracy is absolutely paramount for coherent thought and action. The journey of a message begins with an electrical impulse. This pulse travels down a neuron, reaching its very end. Think of this as the starting gun for a microscopic race. Its arrival signals tiny sacs, called vesicles, to spring into action. These vesicles are like little cargo ships filled with neurotransmitters. They move towards the edge of the neuron, the presynaptic terminal. They stand ready to release their precious chemical cargo. It's a precisely choreographed molecular dance, essential for life. A cascade of events unfolding at incredible speed. Now for the leap across the divide. The vesicles fuse with the neuron's outer membrane. They open up almost like a hatch, releasing its contents. Neurotransmitters spill out into the synaptic cleft. This cleft is that incredibly small space between two neurons. The messengers are now free, liberated into this tiny chasm. They diffuse across this microscopic gulf, a journey of mere nanometers. Their mission is clear: to reach the other side. The next neuron, the postsynaptic neuron, awaits their arrival. Docking at the destination is the next critical step. On the surface of the receiving neuron, there are receptors. These receptors are special protein molecules. They are shaped perfectly, almost like custom-made docking stations, designed to catch only specific types of neurotransmitters. Imagine a key sliding smoothly into its designated lock. When a neurotransmitter binds to its receptor, the message is delivered. This molecular handshake confirms the signal has been received. The information has successfully crossed the synaptic frontier. The impact of this binding is transformative for the receiving neuron. It can excite the neuron, making it more likely to fire its own electrical signal. This is like passing the baton in a relay race, or it can inhibit the neuron, making it less likely to fire. This acts like a brake, slowing or stopping the signal's progression. This decision to fire or not to fire is fundamental. It is the binary code of the nervous system. It's how information flows, how patterns of activity emerge, and how your brain performs its countless complex calculations. Let's meet one of the brain's celebrity molecules, dopamine. It is often called the reward or feel-good neurotransmitter. Dopamine surges when you experience something pleasurable, like tasting delicious food or achieving a long-sought goal. That wonderful feeling of satisfaction and accomplishment. You can thank dopamine for that. It motivates you, reinforcing behaviors by telling your brain, "That was good, let's do it again." It's a powerful driver for learning and seeking rewards. But dopamine's job is broader than just reward. It's crucial for controlling movement and coordination. It also plays a significant role in focus and attention. Now, let's turn our attention to another key player, serotonin. This neurotransmitter is linked to mood and emotions. It contributes to feelings of well-being and happiness. Serotonin helps regulate your emotional state, acting like a stabilizer. It also influences your sleep-wake cycles and appetite. Beyond mood, it's involved in learning and memory. Many antidepressants work by influencing serotonin levels. Serotonin helps maintain a stable inner world, providing calm amidst chaos. The brain's neurotransmitter systems are incredibly finely tuned. They operate with a delicate, precise balance, like a complex ecosystem where every component depends on others. If there's too much of one neurotransmitter or too little of another, or if there are problems with how these chemicals are made by the body, any of these disruptions can upset the brain's intricate harmony. The symphony of neural communication can become discordant. An imbalance in these crucial messengers isn't just a minor chemical shift. It can alter how you feel, influencing your moods and emotional responses. Many mental health conditions involve such imbalances. The connection between brain chemistry and mental states is increasingly clear. Understanding these neurotransmitters is fundamental. It's a grand voyage of discovery into the universe within.